Hello, welcome back. In this session, we are going to learn about network devices. So let's look at the agenda. At the very onset, we are going to learn about what are network devices, then the various network devices like repeater, hub, bridge, switch, modem, router, gateway. Now, what are network devices? These network devices are basically the physical or the hardware devices that are used to connect the various networking sites. Now, let us understand this with the help of this diagram. You can see here, this is an example of a network having large number of blue colored nodes, and these nodes are known as the intermediate nodes. These points are known as end stations. So we have here end station A, end station B, end station C, and end station D. These end stations are connected to the various blue colored nodes of the network. Now these nodes are the intermediate nodes. What is the difference between end stations and nodes? End stations are the actual entities or the systems like the computers, printers, fax machines, laptops, etc. And these intermediate nodes are the nodes which are not responsible for looking into the data packets or the user payload. Let me explain here. A message may be hundreds and thousands bits long. So a message can be divided into smaller data chunks which are known as packets. So basically a message consists of large number of packets. Now, a packet can be divided into two parts. One is known as the header part and the other one is known as the payload part. This payload part consists of the user data. And the header part consists of the control signals. For example, the header part may consist of the port address, then the IP address of source and destination. So, this is a network connection. If a packet wants to be transferred from node C to node T, it passes through the blue colored nodes of the network. The functionality of these blue colored nodes is that they simply forward the data packet looking into the control signal part of the packet and without looking into the user data. Now, in order to transmit these packets to the nodes of the network, there are various networking devices. Some of these are connected to the computer itself, like we have the network interface card or RJ45 connector. So these are parts of the system. Other network devices are not directly connected to the computers or the entities, but rather they are part of the whole networking and they aid in the fast delivery of data. Let us understand what a repeater is all about. This is a networking device which is not directly connected to the computer. Repeater is a physical layer device. It is a physical layer device. Now this physical layer is the lowest layer of the OSI model. Now, what is the utility of this repeater? Let us look at the repeater. This is a networking device that operates at the physical layer of the OSI model. Let us look at this diagram. We can see here that when the signal passes through the network, it can become very weak due to incorporation of noise. So we can see this following figure where there is a pulse, and to the pulse, noise has been incorporated and it has been distorted. So in order to generate clean new pulses, it is passed through the repeater. And you can see here at the output of the repeater, we can get a strong output digital signal. Now let us see how this actually happens. Here we take a comparator. A comparator is a device which can compare two different signals, and based on the value of the two different signals, comparator gives either a 0 or a 1. Now here the input signal, which is having some noise in it, is fed to one input of the comparator, and to the other input we feed a reference voltage. Right. Now if the reference voltage is higher than the input voltage, then the output of the repeater will give a 0. On the other hand, if the reference voltage is lower than the input voltage, then the output of the repeater will give a 1. Let us draw one example here. Let's say this is the original pulse. So this original pulse is 1, 0, 1, 0, 0, 1, 1, 0. Now, while this pulse is getting passed through the network, it may be hit by noise. It may be hit by noise and it may be distorted. Let's say it becomes like this. Right? Okay. Here we keep a reference voltage. This is the reference voltage, which is V reference. Now we are going to set the sampling point at this instance. And we are going to look into what is the value of the voltage along with noise at this instance. Let's say this is instance T1, T2, T3, T4, T5 and so on. Now you can see here at this instant, the reference value here is lower than the actual input value. So the output of the comparator will give a 1. At this instant also, it is at T2 instant, this value is also higher than the reference voltage, so it will give a 1. Similarly at this instant, but you see at this instant, it is lower, so it will be giving a 0. Accordingly, the output will consist of 1, 1, 1, 0. But you see here, you compare with the input, this is totally wrong. That means the signal, the original signal has been overwhelmed with so much of noise that it is getting distorted. So the idea is to place the repeater at smaller distances so that before the signal gets too much distorted by noise, it is caught by the repeater and new clean pulses like this are regenerated. So this is the work of repeater. It regenerates new clean pulses. Let us understand what a hub is all about. A hub is also a physical layer device and it connects multiple devices and it forwards the data. We can say that this hub is a multi-port repeater. So this is an example This is an example of a hub. You can see here, this hub is basically a repeater having multiple ports. So these PCs, printer, laptop and another PC, let's say this is PC1, this is PC2, this is one printer and this is laptop. They are connected to this hub. And this is having a star connection. A star connection is one where a single device is at the central point and to it all the other devices are connected through wire. It is used to forward the packet. Now suppose one data comes to this star point, that is a hub. This hub has no intelligence of its own. It has no intelligence. And it cannot also filter data based on the address. So what it does, it floods whatever data has come to it, it floods the entire network with the data. Flooding means broadcasting the data to all the connected nodes. Now, based on the address, the PC or the printer to which it is addressed to will accept it and all the others will reject. There are two types of hubs. One is called the active hub and the other one is called the passive hub. Now this active hub has its own power supply. But the passive hub does not have its own power supply. It basically captures the power supply of one of the active hubs. Now, in active hub, it is also used as a wiring center. It can be used as a wiring center and it can be used to extend the distance. But in passive hub, it simply forwards packets, forwards the data. It does not have any wiring center and it uses the nodes for its wiring and power supply for the active hub. So this is about the hub. Let us now understand bridge. Bridge works at the second layer of the OSI model and here the data are in the form of frames. It can connect two different LANs. Let us understand this with the help of this diagram. There are two types of bridges. One is called the transparent bridge and the other one is called the source routing bridge. In transparent bridge, the nodes that are connected to the bridge do not have any idea of the existence of the bridge. They understand it by the bridge forwarding and learning techniques which we are going to learn. And in source routing bridge, there is a routing table which has the proper route that the bridge must follow for routing the frames coming from one computer to the other. Now let us look at this diagram to understand the transparent bridge and understand the bridge forwarding and bridge learning technique. You see here this bridge has 3 ports. This is port 1, this is port 2 and this is port 3. To the 3 ports, 3 LANs are connected. LAN A, LAN B and LAN C. To LAN A, few computers are connected. To LAN B, another set of computers are connected. And to LAN C also, computers 1 to 3 are connected. Suppose computer 3 of LAN A wants to send a data packet to computer 2 of LAN B. What happens? It sends the data packet. It goes to the bridge. Now the bridge looks into the data packet. It understands from the MAC address. It understands that it is in port 1. It is in port 1. So it forwards that data packet to port 3 and to port 2. Right. So it is flooding. So this is known as flooding. Now, this data packet, when it goes to LAN C, it can understand that it is not meant for one of its computers, so it rejects. Now, it goes to LAN B, and LAN B understands from the MAC address that it is belonging to one of the computers of its own LAN. So, it forwards the packet and computer 2 receives the packet. Okay. Now, when computer 2 receives the packet, it has to send an acknowledgement control signal to computer 3 of LAN A. So, it sends that acknowledgement packet to the bridge. It goes from LAN 2 to the bridge. Now, when bridge finds the acknowledgement packet from computer 2 of LAN B, it sees that it is coming from port 2 and it is addressed to computer 3 of LAN A. So again it floods the packet to LAN C and LAN A, but LAN C rejects it and LAN A accepts it and it goes to computer 3. So this is the way of bridge forwarding and bridge learning. Slowly the bridge learns about the different configuration of the computers belonging to different LANs. So this is about the bridge. Let us now turn our attention to switch. Now switch can connect multiple devices through twisted pair cables. It is also a layer 2 type of device. So it is also a layer 2 device. Layer 2 is the data link layer of the OSI module. So the switch can use multiple switching techniques. Now there are various switching techniques like circuit switching and packet switching. So with the help of these switching techniques, it can forward the data to its recipients. So this is an example of a switch. This is how a switch looks. There are various ports of the switch to which various PCs are connected. Now this switch has intelligence of packet filtering. It looks into the address and finally sends it to the particular computer. Next we look into modem. This is a combined device for modulation and demodulation. So this is basically how a modem looks. And this is the internal architecture of modem. Since it is a combined device for modulation and demodulation, there are two modules. One is for the transmitter section where modulation is done and another one is the receiver section where demodulation is done. Now there is a line interface part which is directly connected to the transmission medium. This transmission medium can be coaxial cable. It can be fiber optic. It can be twisted pair, etc. And if you want to connect it through a telephone instrument, then there is a point where you can connect it through the telephone instrument. Now there is a digital interface which directly gets connected to the DTE. DTE means data terminal equipment. Now let me explain you with a small example what is modulation. Let's say we have a data which is given as 10 1. Now this data cannot be passed through the transmission medium. In order that it gets passed through the transmission medium, it must be superimposed on a carrier signal. Like the carrier signal is always a sinusoidal signal. This is a sinusoidal signal which can be passed through a transmission medium. Now when these two are multiplied, this original signal, let's say it is message and this is the carrier signal, what you need to do, you need to multiply message and carrier. And at the output of the modulator, you will be getting what? So it will be taking its proper shape, and instead of pulses, now you will be getting the carrier signal over here. Like this. So this becomes a signal now, and it can be easily passed through the transmission medium. This is about modulation. And this type of modulation is called amplitude shift keying. At the receiving end, since you have done modulation, you have to do demodulation to get back the original signal, which is 1011. So this is done by demodulation. So this is about modem. Let us understand what a router is all about. A router is a layer 3 device, and it connects devices of a single network from one LAN to another using a routing table. So basically it is a layer 3 device. Layer 3 is the network layer of the OSI model. This is an example of a router which is connected to the two computers, and this computer is on one LAN. Let's say it is LAN 2, and this is another computer on LAN 1. With the help of the router, we can connect two computers in two different LANs. Now this router is directly connected to the modem, and this modem now gets connected to the internet. So this is a router of layer 3 device. With the help of the routing table, it can forward the data packets to the proper destination. Suppose a data packet is intended to computer 2. With the help of the routing table, there are in between the router and the computer 2, there can be large number of nodes, as we have already seen in the previous slide. So the routing table gives a clear indication about which way the data packet should follow to go to the destination computer. So with the help of the routing table, the router can forward the data packet to the particular computer. Next, we have the gateway. The gateway also connects multiple devices, but in two different networks. Like two different networks having two different protocols. There, the function of gateway is very much efficient. Basically, gateway is a router with a protocol converter. Why the protocol converter? Because if we have two different networks, the two different networks may have two different protocols. So simply using a router there will not be sufficient. There we must have a protocol converter together with the router to route the data. Let's look at this example. Suppose we have network A having, let's say it uses protocol A, and we have again a network B which can use protocol B. So router will reside at this point where it can be connected to the router A. So this router is the gateway having router plus protocol converter. Now this gateway is connected to this router, and this router then forwards the data packets to the connected nodes. Similarly, from the internet through the cloud, it gets connected to network B, and network B has a router B to which all the other devices like B1, B2, B3 are connected. So a gateway is a router with a protocol converter which is connected between two networks working with two different protocols. So here we come to the end of this lesson. Here we have learned what the network device is all about. We have learned about various networking devices like repeater, hub. We have learned about bridge. Then we learned about switch, modem, router, and gateway. We have understood to which layer of the OSI model they belong and what is their functionality. Thank you.